So this last page, since it's an OR problem, really it's just two inequalities and you solve one, then you go back and you solve the other, and then you just tack those two answers together on one graph. So, I actually think it's a little bit easier than the sandwich problem, the and problem. So let's look at example 5. All right, again, so it says, actually let me lower it just a little bit. All right, so it says, here's the first inequality, we're just going to solve it. Here's the second, and then down here you're going to see everything put back together. So here, you know that you just add 7, so you get 12. Okay, so we added 7 to each side. Divide by 4. Now, it's a positive 4, so that's why that stayed. So that's why we get a 3. So we divided by 4 on each side. One solution is x is less than 3. Then, if we go over to this side, take away 2. So we subtracted 2 from both sides. We get 3x greater than 21. Okay? Again, divide that 3 out since it's positive. Nothing flips. The symbol stays the way it is. So that's a 7 because we divided by 3. So here are the two separate inequalities. So x is less than 3 or x is greater than or equal to 7. So our answer, it just all comes together as one final answer. So the solutions are all real numbers less than or equal to 3 or greater than or equal to 7. So now let's just put this one on here. It's a solid circle, a closed circle because it's equal. Numbers less than 3 are to the left. Okay, it's another closed circle at 7 because it's equal. Numbers greater than 7 are to the right. So the final answer, the final graph, is both of them on that same number line. So that's the answer to the OR problem. All right? So then you've got 3 problems at the bottom. So you can go ahead and try them. Again, I'll just also do them so you can compare yourself. And then we should be good for all of these compound inequalities. Okay. All right, let me scroll this. Again, I kind of see it as 3 pieces. So, all right, now to get that x by itself, I divide by 4. Alright, so x is between -2 and +4. So that's how I graph it. -2 is on the lower end. It is an open circle. 4 is at the upper end. It is an open circle. And then x, our numbers that we can choose from, are between those two. Okay? So that's that answer. Same approach for this one. Okay, just remember with these types of problems, with the sandwich problems, you always look in the center where the variable is in order to know what to move. So since the x is in here, those are the numbers that I need to move. So that's why I added 3. -6, 2x, and 4. Since this has a 2 with it, that's why I'm doing a 2 on all 3 sections. All right, so there is that inequality. So now x is between -3 on the lower end, so that is an open circle because it does not have an equal to. 2 on the upper end, and that's a filled circle because it does have an equal to, and x are the numbers in between. Okay? So that hopefully has set us up a little bit better for and problems, because we're going to do some sandwich problems, some and problems on the next lesson as well, okay? So now let's look at that last problem. Oh, I guess that's as low as it'll go. So, or that's as high as it'll go. So it's just 2 inequalities. Let's solve them, and then we'll put them up there on the graph. So we'll put them together on the graph. So for this one, add 6. I get 2x is less than 4. Divide by 2. There's no flipping the symbol, so x is just less than a 2. All right, this one, take away 1. I get 5x is greater than or equal to 25. Divide both sides by 5. There's no negative, so the symbol is good. Stays the same. So even though we treated them as 2 separate inequalities, because they were written as one problem together, we graph them together, okay? So, all right, so let's just put them both on the graph. Open, and to the left, this one's closed, and to the right. Okay? And so that's the answer with both of them together.